So, what is an ocean? Humans have been living next to oceans for millennia, so you'd think this would be a fairly straightforward question. They're wet. They're really big. They interact with the atmosphere, so they generate storms, even hurricanes. They're full of fish, and at their deepest point, you could drop Mount Everest into the ocean and it would disappear without a trace. And at their greatest depths, they're crushingly deep. Now, if you were to ask an astronomer what an ocean was, they might tell you something about the Goldilocks zone. They might say you find oceans in those orbits which are not so close to the sun that they boil away, and not so far from the sun that they freeze solid. Carl Sagan said we live on that pale blue dot. A fragile planet, unique for its watery beauty. Yet, as we've explored oceans, we've discovered that we don't really understand them very well at all. Historically, we explore oceans with ships. It's kind of an expensive proposition because ships are expensive. It has its element of danger as well. And because oceans cover more than 2/3 of our planet, I don't think you'll be very surprised if I tell you that we actually haven't explored very much of the ocean at all. And as a matter of fact, our scientific understanding of the ocean is rather poor. So we've worked hard to develop new tools for extending our reach. Increasingly, we develop robots to explore and understand the ocean. Think exploration robots. Now, the first of these robots were actually pretty simple. They were suspended from the ship by a cable. We kind of affectionately called them a dope on a rope. And they weren't very mobile, right? They were kind of married to the ship. So those of us on the robotics side of the community conspired to cut the tether, and we created an entirely new class of systems, systems that were mobile, that could roam the ocean at will. Now, the problem is in the ocean environment, we have some real challenges. And one of the really big ones is that, unfortunately, for all practical purposes, radio waves don't penetrate. You see, seawater has salt in it, and the salt makes the ocean a conductor. And as a consequence, all of the usual radio communication systems we use, the GPS satellite system that we depend on to know where we are, all of those things disappear as our robot descends beneath the waves. And so as a consequence, we have to make our robots autonomous or they won't survive. You can kind of think autonomous or die. We put them into an environment which we understand very little. You can kind of contrast this to a robot which has developed maybe a self-driving car, where the roads are designed by people, they're built by people, they're mapped by people. Our robots go into an environment where the maps, if they exist at all, might be completely wrong. When Malaysian airliner Flight 370 took off from Kuala Lumpur for Beijing and disappeared, in those frantic days immediately afterwards, searchers figured that it probably had crashed into the Indian Ocean somewhere off the west coast of Australia. There was a robot built by Bluefin Robotics, a company that I co-founded, being tested off of Hawaii. And the operating team there quickly wrapped up their operations and deployed to the Indian Ocean. Now, this was a challenging search in many ways, but not the least of them is that our maps of the Indian Ocean are particularly bad. So bad that when the operational team put this vehicle in the water for the first time, they didn't realize the water was much deeper than they thought it would be. In fact, a half a mile deeper. Deeper, in fact, than the rated depth of the vehicle. Fortunately, the vehicle has a lot of software on board, and it recognized that it was being asked to do something it shouldn't. It returned to the surface, probably thinking in its little robot brain, what the heck are they doing? And as events transpired, the bluefin engineers decided that their designs were conservative enough that in fact they could dive the full depth, and so they continued with the search. But the point is, we're putting these robots into an environment we don't understand at all. So let's talk about failure. Gene Kranz was the mission director through much of the Apollo program. As a matter of fact, he is most famous for leading the team that brought the Apollo 13 crew back to Earth against all odds. He titled his autobiography, "Failure is Not an Option." I'm a little embarrassed to say that before I prepared for this talk, I actually thought that was an Arnold Schwarzenegger quote. And it is a little funny to me because in the exploration business, failure is not only an option, it happens all the time. And the problem you're confronted with is preventing little failures from becoming big failures. So when an oceanographer goes to sea, as they often do, and a part breaks on a cruise, they've got a problem. There's no repair person who's going to fly out in a helicopter and fix it. There's no parts depot around the corner that they can go to for spare parts. They have to make do with whatever they brought with them on the ship and their own ingenuity. In the business, we call this a field save. And I've seen some great field saves. One time, we were running a field program in the Arctic. And as we recovered our vehicle through the ice hole, we broke a blade off of one of our main propeller. It was bad news. It was a disaster. And it was a disaster because we'd had a very difficult time getting all of our equipment out on the ice. And one of the boxes that hadn't made it, I'm sure you can guess what's coming, was the box with our propeller. However, we did have a lot of building materials that had made it. And one of my colleagues took the epoxy that we had, and he made a mold using the remaining propeller blade. And then he cast a new propeller inside of that mold using, if I recall correctly, a tie wrap as a stiffener. It was amazing and it worked beautifully. We used it for the entire rest of the field deployment. So my point is that failure happens. It happens a lot when you're exploring. And what you need to be able to do is fix things, adapt, and move on. The other thing that happens when you explore is that you're surprised. You're going into an environment that you don't understand very well. Perhaps there are things there that you don't know exist. You'd be surprised how often we discover new species in the ocean. And the problem is we program our vehicles to recognize the things that we know to expect. So as a consequence, when something really surprising happens, often our robots are completely oblivious. So I'll give you a great example of this. A colleague of mine, Amy Kukulia, likes to use her little robot to follow sharks. What she does is she takes these tags and she attaches them to a shark, which is an exciting procedure. And this tag emits an acoustic ping which the robot can follow. The robot has a camera on it so Amy can see what the shark is doing. I think of this as kind of stalking for science. Anyway, the first time that she did this, when she pulled the robot out of the water, it had scratches all over it. She had no idea what had happened until she watched the video. It turned out, while Amy's robot was following Shark A, Shark B was following Amy's robot. You know, it turns out we've gone back through our data, and as surprised as Amy was at the time, it turns out that things go bump in the dark all the time down there. I once recovered a vehicle which had been motoring around in Monterey Bay for several days with great white teeth sticking out of its fairing. Apparently, sharks have some sort of robot catch and release program. So the point is, though, this is really the very definition of oblivious, because these robots had no idea that they were attacked. They just kept motoring right along afterwards. Fortunately, one of our other colleagues at Woods Hole, Yogi Girdhar, is working on this. So here's Yogi's little robot. paddling around underwater. What makes it cool is it's actually using a form of unsupervised machine learning on board, which is so light that it can classify things on the fly. What you see on the right side of the screen is what the robot sees. And the red dot is an area which actually doesn't fit its existing classification scheme. This is an area which is surprising. And the robot reacts to that surprise by driving towards it. Pretty cool. So it finds the coral head interesting. It finds the diver that swims in front of the vehicle interesting. It's a vehicle. I'm not sure what the diver is saying, something like, "Get it off of me." Laugh if you will, but I think this is the future of robots. This is a robot that can be surprised. And what's more, it's curious about what it finds surprising. It's probably the future of exploration robotics. Now, it turns out that one of the truly great adventures that is going on in the ocean today is the attempt to understand life. And probably the greatest discovery occurred in 1977 entirely by accident. There was a group out there in the Pacific, and they lowered their dope on a rope out there into the deep Pacific. And what their robot saw was unusual thermal anomaly, a region which is surprisingly warm. Now, the deep ocean, it turns out, is pretty much, think 35 or 36 degrees Fahrenheit. It's kind of pretty much the same temperature anywhere. So if you see a region which is a little warm, this is something which is worth taking notice of. And so they called over to their friends who were diving nearby on Woods Hole's Alvin submersible and asked them to come take a look. And in fact, they brought Alvin over, and as Alvin descended to the seafloor, they found this incredible environment. There were superheated streams of water coming out of the seafloor, giant chimneys and spires, and perhaps most exciting, surrounding them, a very unusual range of sea life. Strange giant tube worms, large white crabs, weird shrimp with what we now realize are photoreceptors on their back. We don't know why yet, still. And even a purple octopus. Now the thing is this is deep in the ocean where there is no sun. These creatures are born in the dark, they live in the dark, and they die in the dark, never knowing that there's a sun or a sky above them. There's no photosynthesis there. There's no energy from the sun being turned into chemical energy to sustain these ecosystems. As the scientists peered out of their little porthole into this unique and strange environment, they were looking at a form of life that we hadn't known existed at all. Now, at the same time, there was another robot adventure underway. The two Voyager probes had been launched in 1976. The Titan rocket that hurled them into space threw them past the moon, past Mars, past the asteroid belt, out to the outer solar system, which is the realm of the great gas giants, Jupiter, Saturn, Uranus, and Neptune. 3/4 of a billion miles from the sun in 1979, the Voyager spacecraft approached the Jupiter system. Now, I say the Jupiter system because Jupiter is big. It has a whole collection of moons. And some of these moons are so big and bright that if you have a pair of binoculars, a decent pair of binoculars, you can actually see them from Earth. And as spectacular as Jupiter is as a planet, in fact, the moons are the star of our story. As Voyager 1 flew through the Jupiter system, the discoveries just rolled in. The moon Io looked like a pizza. And as they looked back, as they exited the Jupiter system, they saw this strange blemish on the side of the moon. It turned out they were seeing an eruption that was so violent, it was throwing material hundreds of kilometers into space. Apparently, Io's orbit around Jupiter generates these internal tidal stresses that heat the interior of that little moon and create a level of volcanism that's truly astounding. Unlike our geologically dead moon, Jupiter's moons are very much alive. Now, the second Voyager that flew through Jupiter's system followed a different path. And one of the moons it flew by was Europa. And there was a collective gasp because Europa was a ball of ice. And it was missing something. It was missing craters. It turns out that objects that had been around in our solar system for a while had been knocked about by the debris left over from the formation of the planets. Just look at our moon, full of craters. So if there are no craters or very few craters on the surface of Europa, you have to ask what removed them. They thought to themselves, maybe there's liquid water under that icy crust that came up and resurfaced the moon. And if there's liquid water, is it possible there's an ocean on Europa? Now, many years later, and after several missions to the Jupiter system, we know there is a salty ocean on Europa. It lies under 5 to 10 kilometers of ice. Those tidal forces that heat the inside of Io heat the inside of Europa as well. And it doesn't take a lot of imagination to think that perhaps there's volcanism there too. And where that volcanism comes in contact with seawater, perhaps there's hydrothermal vents like we have here on Earth. And if there are hydrothermal vents like we have on Earth, maybe there's life. We need to go find out. And we are. So it turns out that what we thought was an ocean was incomplete. Europa has an ocean. And if our math is right, that ocean is bigger than all the oceans on Earth put together. And Ganymede has an ocean, and Titan has an ocean, and Enceladus has an ocean, all moons of the outer planet. So NASA now has 2 missions underway to return to Europa. One will repeatedly fly by it, and the second will attempt to land a lander on it, to begin that process of, we hope, gradually making our way through that ice cover into that ocean on a distant planet. But this is a grand challenge, and it's going to require a different kind of space robot and a different kind of exploration than we have today. For one thing, it's very hard to have a conversation with a robot on Europa. Because it's 2 hours away. It takes an hour for your signal to get there and an hour for your signal to get back. So if that little robot is descending through that crust into the ocean and it sends a message asking for help, it's going to be 2 hours before it gets a reply, and that's if we replied immediately. Now, of course, we probably wouldn't reply immediately because we'd have to look at the data and figure out what was going on. All the while, the clock would be ticking. Possibly the robot wouldn't be there by the time our reply got there. So as a consequence, we're going to have to make robots that operate in the unexplored, unexpected world of these oceans. They'll have to be able to adapt. The other problem is the way we cycle space missions. What happens is we send one mission out which teaches us something new about the environment. We take that information back again, and then we construct the next mission, design that spacecraft, and send it out to space to follow up and make the next set of discoveries. And that iteration cycle takes a long time. It might be 10 years. It might be longer. It's a very long time, and it's very expensive. So you have to ask, as you go to the outer solar system, is there a better way to do this? Maybe. Maybe we're building our robots in the wrong place. Maybe what we should do is we should send a factory out there. And we'll send a bunch of parts and maybe some 3D printers and some assembly robots. And that way, when the next little robot lands on the surface of Europa and sends its lessons back, what we'll end up doing is designing a new robot here on Earth, but we'll send the plans back to Jupiter. And that little factory will manufacture that robot, maybe a burrowing robot, up there in space, in orbit around Jupiter. It's kind of an amazing thought. But you can see the pieces are all around us. Maybe that's how we find life. We send robots out to explore and then to build. So maybe years in the future, our grandchildren will be in a living room listening, perhaps with their children, breathless, to the news from Europa as a little robot makes its way into that alien ocean. That robot will be able to adapt. That little robot will be equipped with an onboard sense of wonder. And so, when we first encounter life that arose on another world, perhaps the way we'll encounter it will be through the eyes of our robots. Perhaps, as we explore these distant worlds, we'll see them in a new way. And if we do discover life out there, it will shake the world. Because if life arose twice in our tiny solar system, as we look to the stars, it must be everywhere. Thank you.